Hi, this is Mrs. Rodriguez, your algebra teacher. This video is a review for the chapter 11 quiz that's coming up. These problems are from a practice quiz in your textbook. So what I recommend that you do is once a problem comes up on the board or on your screen, pause it, try to solve the problem yourself. And if you get the correct answer, great. Move on to the next one. If when you're listening to my explanation, you're confused about something, make sure make a note of which problem it is, and then please call, text, email, or stop by my office hours, and I'd be happy to go over those problems with you and get all your questions answered before you take your quiz. Okay? All right, so let's go ahead and get started. All right, so like I said, this is a review for the Chapter 11 quiz for algebra, and this is on page 705 of your textbook. All right, so the first section talks about inverse variation, and we can use one of these two equations. So we have either y equals k over x, or x times y is equal to k, okay? And notice that y cannot be equal to 0, okay? So it says in an inverse variation, the product of two values remains constant, okay? And recall that a relationship of the form y equals kx is a direct variation. The constant k is called the constant of variation or the constant of proportionality. Okay, so it says here, assume that y varies inversely as x. Write an inverse variation equation that relates x and y. Okay, so the first thing that we need to do is figure out what k is, right? Because remember, we want the equation to be y equals k over x. So we know what y is and we know what x is, but we don't know what k is. So in order to figure out k, we use the equation x times y is equal to k, okay? Because we're told it varies inversely. So we would plug in x, 12 for x, and then -2 for y. So we multiply 12 times -2, that's -24. So that is the value of k. All right, so now what we do is we have our x times y equals k. Now we know what k is, so x times y equals -24, and we want to solve for y. So we would divide both sides by x, and we get y equals -24 over x. So that would be our inverse variation equation, okay? Then we also have this product rule, and it comes from when if you have two solutions of an inverse variation, you have an x and a y value for one solution, and maybe you have the x value for the other, but not the y, okay? Then when you multiply the x and the y values of the first point, or the first set of values, that equals the constant. If you multiply the value, the x and the y values of the second point, that's also equal to the constant. So therefore you can set them equal to each other, okay? And that is the product rule for inverse variations, okay? So it looks like this, the x value of the first point times the y value of the first point is equal to the x value of the second point times the y value of the second point. Or you could use this proportion as well, okay? So here it says to solve, assume that y varies inversely as x. So we're given y when x equals 2, and it says to find y when x is equal to 4. So we're going to use that product rule. So the x value of the first point times the y value of the first point is equal to the x value of the second point times the y value of the second point, okay? So we plug in our values. The x value of the first point is 2. The y value of the first point is 3. The x value of the second point is 4, and we don't know the y value of the second point. That's what we're being asked to find, okay? So we've got 2 times 3, which is 6, and then 4 times y, the y value of the second point. So then I would divide both sides by 4, and I end up with 3 over 2 is the y value of the second point, and I can rewrite that as 1.5. That is the value of y for the second point, okay? All right, so then the next section talks about rational functions, okay? So a rational function can be described by an equation of the form y equals p over x, where p and q are polynomials and q is not equal to 0. So recall that your denominator cannot equal 0, okay? Okay, so since division by 0 is undefined, any value of a variable that results in a denominator of 0 in a rational function is excluded from the domain of the function. These are called excluded values for the rational function, okay? And then what ends up happening at those excluded values, that's where you have an asymptote, okay? So here we have an asymptote, a horizontal asymptote. Here we have a vertical asymptote, okay? And that helps us to draw our function or graph our function. So it says state the excluded value for each function, okay? So we have to set our denominator equal to 0. So we have x minus 6 equals 0. So then I would solve by adding 6 to both sides. So x is equal to 6. So if we were to graph this, we would have a vertical asymptote at positive 6, okay? All right, then it talks about asymptotes, and it says here, a rational function in the form of y equals a over x minus b plus c, where a is not equal to 0, has a vertical asymptote at the x value. Okay, that's the one we were just looking at, where we set the denominator equal to 0. Okay, and it has a horizontal asymptote at y equals c. So when you have a function, if something is being added or subtracted to that function, that is going to be your horizontal asymptote. If nothing is there, then your horizontal asymptote is 0. Okay? All right, so here we have a function, but nothing is being added, right? Plus nothing. So our horizontal asymptote is going to be 0. Okay, so y equals 0. And it's asking you to identify the asymptote. So we need the, this is the horizontal asymptote. We also need the vertical asymptote, and that's where x is equal to 0. So we set 2x plus 4 equal to 0. And then we would solve by subtracting 4. So we get 2x equals negative 4. And then we would divide both sides by 2. So x is equal to negative 2. So this would be our vertical asymptote. Okay? So here we have a vertical and the horizontal asymptote identified. Okay? Then the next section talks about simplifying rational expressions. So what we do is to simplify a rational expression, you divide out any common factors of the numerator and the denominator. So the example it gave us here is if we have b times a and c times a, well, they have a common factor of a. So you would factor that a out and you're left with b over c. Over here, they have a common factor of 3. We factor out that 3 and we're left with x minus 3. Here they have a common factor of 4. So you factor out that 4, and you have 4 times x minus 3. So that x minus 3 over x minus 3 is 1, and you're just left with 3/4. Okay? So let's look at a couple of these. So here we have z minus 5 over z squared minus 7z plus 10. So we need to see all of the factors, right? So we have to factor this trinomial down here. So we have we need the factors of positive 10 that add up to negative 7. So we're multiplying a negative times a negative, and negative 2 plus negative 5 is negative 7. Okay, and negative 2 times negative 5 is positive 10. Okay, so then we see, okay, we've got z minus 5 in our numerator and our denominator. So that would simplify, those would simplify to 1. So we're left with a 1 in our numerator. In our denominator, we have z minus 2. So now this is simplified. And then it also says to state the excluded values. Okay, so remember that is where we set our denominator, z squared minus 7z plus 10 equal to 0. Now the nice thing is we already factored this, so that's z minus 2 times z minus 5. And so we need to set each one of those equal to 0. Still seeing a lot of students not do this last step, okay? So what we do is solve for z. So we would add 2 to both sides here. So z is equal to positive 2, not negative. And then here we add 5 to both sides. So z is equal to 5, okay? So these are our excluded values. Okay, so then it talks about multiplying rational expressions. So to multiply fractions, you would multiply the numerators and multiply the denominators, and you use the same method to multiply rational expressions. So here if we had x over 2x minus 3, and we're multiplying by 4x squared times 5, then you would just multiply your numerators, x times 4x squared, which would be 4x cubed, and then 2x minus 3 times 5 would be 5 times 2x minus 3. And then, of course, just like when multiplying fractions, you would simplify if possible. Okay? So here we have a squared plus 2a plus 1 over a plus 1 times a minus 1 over a squared minus 1. So what I want to do first is I want to factor everything, and then I'll multiply my numerators and my denominators. So for a squared plus 2a plus 1, I would factor that, and I have the factors of 1 that add up to 2. So that would be 1 times 1. And then I have a plus 1 as my my denominator. And then I have a minus 1 over a squared minus 1, which is a difference of 2 squares. So that's a plus 1 times a minus 1. So if I multiply everything straight across, I have a plus 1 times a plus 1 times a minus 1. And then I have as my denominator a plus 1 times a plus 1 times a minus 1. So then what I'm going to do is simplify. So a plus 1 over a plus 1, that simplifies to 1. A plus 1 over a plus 1 simplifies to 1. And a minus 1 over a minus 1 also simplifies to 1. So 1 times 1 times 1 is 1. And same in our denominator. And 1 divided by 1 is 1. So when we're all said and done and we simplify everything, we end up with an answer of 1. Okay. Then it talks about dividing rational expressions. So remember, when you're dividing fractions, you multiply by the reciprocal. You keep the first fraction, you flip the second fraction, and then you change division to multiplication. So if we had something like x minus 3 over x divided by 2x squared over 5, you would keep that x minus 3 over x, and then you would flip this second fraction. So our denominator 5 becomes the numerator, and then 2x squared becomes our denominator. And then we're changing division to multiplication. And then again, you would multiply your numerators, and then you would multiply your denominators, and then simplify if possible. Okay? So let's look at one of these. So we have x squared plus 7x plus 12, and we're dividing by x squared minus 25. Now I want to factor, I know I need to factor everything, so I want to factor that first. So the factors of 12 that add up to 7, so that would be 3 and 4, right? Positive 3 and positive 4. And then in the denominator, I have a difference of two perfect squares. So that's x plus 5 times x minus 5. And divided by, over here I have a difference of two perfect squares, x squared minus 9. So that's x plus 3 times x minus 3. And then in my denominator, I have a common factor of 2. So 2x divided by 2 is x, and 10 divided by 2 is 5. Okay, so then what I would do is keep my first fraction, x plus 3 times x plus 4 over x plus 5 times x minus 5. I flip my second fraction, so 2 times x plus 5. My denominator is x plus 3 times x minus 3. And I change division to multiplication. Okay, so now I multiply my numerators, so that's 2 times x plus 3, x plus 4 times x plus 5. And then in my denominator, I multiply those. I have x plus 5 times x minus 5 times x plus 3 times x minus 3. Then I see if I can simplify anything. I've got an x plus 5 in both my numerator and denominator. I've got an x plus 3 in both my numerator and my denominator. And that's it. So I write down what I have left, 2 times x plus 4 in my numerator. And then in my denominator, I have x minus 5 times x minus 3. And that would be my final answer. All right, so hopefully this video was helpful to you. If you are at this point of the video and there were some problems that you had questions on, of course, please stop by my office hours or call, text, or email me, and I'd be happy to answer your questions, okay? You have a great day and good luck on your quiz.